The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. It is right at 9 a.m. Pacific time. I want to go ahead and thank you for joining us on this webinar, How to Analyze a PC Board in the Cloud with Ansys HFSS. We're going to get just started here in just a few more minutes. So hang tight. We're going to wait for a few more people that are rolling in, and we will begin. Hang tight. Okay, everyone. Welcome to the webinar. This is the first part of our series in EDA. Thank you for joining today. Today, we're going to discuss how to analyze a PC board in the cloud with Ansys HFSS. In this series, we're going to cover a variety of things to help existing and new users get more out of the platform. If you're new, then welcome. You're going to learn much faster as we're going to cover some really interesting FAQs. If you're a pro already, I'm sure Riaz is going to cover some deeper topics that you may not already know about. Today, we're focusing on EDA analysis. You're going to be surprised at some of the features we packed into the platform. My name is Robert. I'm part of the marketing team here at Rescale, and presenting today is Riaz Liyakath, a member of our prized solutions team. Just a few items before we get started. First off, we are recording this webinar, and we will be distributing it at the end of the week, as well as the end of the month for our monthly newsletter. Secondly, if you have any questions during the webinar, please make sure to type them in the questions panel and GoToWebinar, and we will address those at the end of the webinar. Riaz, I'm looking at you. Thumbs up?
Yes.
Okay, it's all yours.
Thank you, Robert. Good morning, everyone. My name is Riaz Liyakath. I'm a solutions architect based in San Francisco. At Rescale, I help customers move from on-premise HPC systems to cloud. My background is in electromagnetics, and I worked at Ansys before as an application engineer, and I have also worked as a wireless chip design engineer in the past. Today, I want to share my experience about how you can run all these PCB simulations on the cloud. So let's get started. Right. So if you look at the PCB designs in the past few years, It's becoming very complex. PCB designs are very important for a variety of different applications. For example, mobile phones, autonomous driving systems, mainly because of the high data rate that they support. In the last 10 to 15 years, maybe in 10 years ago, the PCB boards had like a couple of layers and a few components. But today, with increasing complexity, there are close to 50 to 60 layers and there are hundreds of components. So engineers rely heavily on simulation or virtual prototyping to design the PCBs. And usually they do not run just one simulation, they run a variety of variations to make sure that they get the right design to meet the spec. So think about it. A single simulation has become very complex and it's very compute intensive, so it requires a high amount of high performance compute. Now, if you have n number of variations, today there is no high performance computing available for most of the customers. The way semiconductor industry companies work today is most of them have a high performance computing cluster or a farm which engineers use to run the simulation. The problem is the clusters might be able to solve the problems today, but next year when the size becomes double and if the number of chips increases, they just don't have capacity to run the simulations. And that's the reason semiconductor industry is really looking at migrating to the cloud. One other interesting thing that we have noticed in the past is usually when chip and board design engineers are towards a mask tape out, they tend to do a lot of variations, right? So there is a peak demand during those times. The on-premise HP systems, which have fixed capacity, just cannot meet this demand. So this has also been a critical reason why cloud migration is the next step for the EDA industry. So in this journey, I want to talk about how Rescale adds value to this industry. So Rescale is a single platform to run HPC simulations on the cloud. So if you think about it, we have close to 300 plus softwares, and we have like close to 15 to 20 EDA softwares from Cadence, Ansys, Mentor, and as we speak, we are also continuing to add more softwares, especially for EDA. The key value and benefits that we as Rescale bring us is we have technical people here who understand the industry. For example, I come from semiconductor industry. We also have folks from different industries, for example, manufacturing. So we have the technical know-how to ensure that the application is optimized to fully take advantage of the hardware. And when we talk about the hardware, Rescale is a multi-cloud platform. So essentially, you can run it on any cloud, anything of your choice. You can go for AWS or Azure or IBM or Google Cloud. The options are plenty. So overall, if you think about the user experience, so I want to highlight three important things Rescale brings. The first thing is I spoke about it. It's optimized. So we as a company ensure that your application is fully optimized to take advantage of your hardware so that you get good cost performance. And the second part is scalability, right? So this is a topic I briefly touched upon. So you might have resources to run a problem today, but tomorrow the problem size could double. So you might want to have like a scalable resource. So that's where Rescale comes in, because we provide unlimited resources and you can add as many cores and nodes as you go. And the third thing is turnkey solutions, right? So today, if you have like EDA tools, for example, Cadence Virtuoso or like Spectre, and you might want to run these on the cloud, you can go and approach like the cloud service providers like AWS directly. So they would provide all the building blocks that you need to set up an infrastructure, networking, and security. The question is, do you really want to spin the wheel and go and build up this sort of an infrastructure, or do you want to use something like Rescale, where we have actually configured the entire chain for you, right? It's a turnkey solution where you can just log into the browser, select your software, and get started as soon as possible. And one thing that we customers usually ask for when think about running simulations on the cloud is data security. So we adhere to the strictest standards, and we are like ITAR, HIPAA compliant. So the data on our platform is very secure, and we also ensure that we use multi-factor authentication, single sign-on, and other security aspects as well. So with that, I'm going to get to the best part of the talk today, which is to talk about the workflow for running PCB analysis. So the workflow, as I'm showing, is very streamlined and straightforward on the platform. So let's assume that there is a user. He has an input file, so he worked on a board design, and then he came up with the layout and everything. He set up the boundary conditions. Everything is ready for simulation. So the pre-processing work has been done. Now the next step is, so he is going to upload the files onto the Rescale platform. Usually to connect to the Rescale platform, there are multiple ways of doing it. You can do it through a web browser, you can do it through command line interface or through the API. But the easiest would be web browser, and I want to talk about how you can use the web browser to submit jobs today. So the user would upload his PCB input file, and after that the next step is to choose the software of choice, right? For example, you might want to analyze this using HFSS, might want to analyze using SI wave, you might want to analyze this using Sigrity, right? So the choices are plenty, and it's up to the user to pick and choose whatever he wants. And after that, again, like we can pick any type of hardware. It could be like a few cores, it could be ones with high memory nodes, it could be ones with GPU. So you have all the different options ready to go. So once you pick both of them, that's pretty much it. We are ready to run the simulation, and once the simulation is done, we can do the post processing. So let's move to the live demo. In this section, what I want to focus on is first briefly talk about the PCB model that we are going to analyze today. So it's a PCA Gen 3 board. I wanted to pick an example which appeals to everyone. So I'll briefly go over the setup for that model. The software today that we are going to use is called HFSS, which stands for High Frequency Structure Simulator. It is a 3D electromagnetic solver, and today essentially we are going to run the simulation and look at S parameters. The workflow that we are going to start with is a batch workflow or a non-GUI workflow. In the sense, like we have our input file and then we are going to run it on the cloud. The last section of my demo is I'm also going to touch upon a couple of custom workflows and automation, because again, this is an important benefit on the Rescale platform. We have developed workflows today for customers, but there is always room for customization and automation, right? So for example, if you want to run a batch job and automatically export the S parameters, we can absolutely do that. And also, like for example, you've seen in certain cases, you might want to break the problems into two steps. Typically, you might want to use a fewer number of cores for the meshing, and you might want to use more number of cores for the frequency sweep, right? So those are the things that's all available on the platform today. With that, let me jump into the demo. So I'm using a virtual desktop here, and this is the model that we are going to be analyzing. So it's a PCI Gen 3 board, and so I imported this using a board file from Cadence. So for this particular analysis, I don't want to analyze the entire board. I'm just going to analyze a portion of it. In the sense, like I'm just going to cut this portion, set up some ports. So the ports could be like gap ports and coaxial type ports. And then I want to look at a couple of differential pairs and look at their S parameter data. So one thing that I want to highlight is usually once the simulation is done, people do post-processing, but you can see that the GUIs that we have is very snappy. So essentially, if you want to do pre or post-processing, we do have like, Windows, Linux, or even like beefy GPU-based GUIs as well. So let's look at our problem at hand. So this is the portion that we are going to be analyzing today. And for this particular model, I have set up the ports. So I basically have 2 ports on the edge connector side, and I have 2 more coaxial ports, right? And then this is a 3D electromagnetic analysis. So I'm going to, my meshing frequency is going to be 1.5 gigahertz. And then I'm going to sweep this problem from DC up till 1.5 gigahertz. So essentially, this is my run. And once this, so if you think about it, you would do all this pre-processing on your local machine. And once you do the pre-processing, you're just going to export an archived file, which we are going to use as an input for our batch run. So with that, let's start setting up this problem so that we can run it in the batch mode. As I mentioned, the workflow that we have on the platform is very streamlined. So you start with your input file, software and hardware, and then you run the simulation, right? So usually when I like to start a simulation, I would like to give it a name. So in this case, let's just give it webinar, right? So and when for the input files, so if you have files on your local computer, you can upload that. And usually for the upload process, we take advantage of multi-threading, so that we use all the cores to optimize the network bandwidth to upload the data faster. If you also have files on your cloud storage, so you can also use that as well. So in this case, I'm just going to use an ADT file for my simulation, right? So I have my input file. The next step is to choose the software. So as I mentioned, we have close to 300 plus softwares which we can support today. For today's analysis of this PCB, I'm going to be using HFSS. So once you pick the software, so you can pick the version of choice. So what we also do is, like, we also maintain a laundry list of all the older versions as well. And this is something that I've seen customers in the semiconductor industry. Usually if they start a project, they would like to stick to that version for a couple of years. So the benefit of us having all the older versions is really appreciated. So for this case, let me pick the latest version. And then the only other thing is, after the software is picked, you can see that the command line is automatically populated. So I don't need to do anything additional. All I need to do is I need to just replace it with the input file. So with that, my software setup is ready. In terms of the licensing, so there are a couple of options. If you have your own license, so you can bring your own license and use that to run the simulations. Or for this particular case, I'm going to be using a trial license. The next step is the hardware, and this is where I think like Rescale shines and brings a lot of benefit. At a high level, we have two different core types. You have primary core types. Usually a core type is a particular type of machine from a particular vendor. For example, Onyx is a machine from AWS, Mercury is one from Azure. As a user, like, you always have choices on what type of core types to pick. But as Rescale, as a company, based on our experience of working with different customers in this industry, we can also provide recommendations on what code type would be ideal to run a simulation. For example, when it comes to HFSS, we usually seen that HFSS requires high memory in the head node, and Zinc is always a good option because it has close to 15 gigs per core, and if you pick a node, it's close to 500 gigs in RAM. So I can pick the number of cores here. And the wall time is again a feature to ensure that the job does not keep running infinitely. And a particular use case could be like, for example, I might submit my job today and go on a vacation for a week. I don't want my job to keep running throughout the week if something is wrong, right? So if I set a wall time of maybe a couple of hours, after 2 hours is done, the job would be terminated, right? So this gives more control to the user on how they actually submit the job. As we pick a number of cores, so this is going to be a hardware summary. So the type of core type that we are using here is Zinc, and the overall memory for this particular cluster is going to be 122 gigs, and we have a total of 8 cores. So if I run this for an hour, it's going to be like $1.67. Again, this is all street pricing depending on the particular core type. So with that, that's pretty much it. The post-processing step is purely optional. So some softwares have some post-processing options. If you have that, some scripts, you can attach it. If not, you can just continue, and we are ready to submit this job. So when you submit a job, so there are four steps which usually happens. The first step is called validating input. What does that mean? It means that we look at your input file, we look at the software that you are using, and make sure that you have the correct command line, you have the correct input, you have the license and the budget to run the problem. So this validating input ensures that all these checks are passed before we start a cluster. And the next step is to start a cluster where, based on the configuration that you provided, in this case, I asked for like 8 cores with 122 gigs. So we are going to spin up a cluster. We ensure that we only pick all the healthy nodes. And once the cluster is stand up and it's up and running, we are going to run this job. And once the job is completed, we are going to tear down the cluster. So this entire process from starting a cluster, running a job to tearing down the cluster is orchestrated on our platform. So usually like the validating input takes about like a few seconds and starting a cluster takes a minute or two. So while this job is running, so I want to go back and show you a couple of other cool features on our platform. So if I go to the jobs menu, so this contains a list of all the jobs that I ran on the platform. So this has a couple of benefits, right? One, if I ran a job like 6 months ago, I always have the option of going back and checking what my input file is, what is the results that I was getting. So all that is collected and documented. And two, if I want to make a tweak or change something, I can always clone the job and start running it today, right? So we ensure that we keep all the information in one platform. So I have another job, the similar job that we launched today. I submitted it and it's currently running. So one of the features that I want to highlight is when you run a job, we have this feature called as live tailing. So what this means is it provides a live snapshot of the latest process in the simulation, right? So for example, I can look at the log file here. So essentially, by looking at the log file, I can really understand, am I in the initial meshing stage, am I in the adaptive meshing, or am I in the frequency sweep, right? If something went wrong and this job got terminated, I always have the option of going back and checking and at which portion of the simulation was there a mistake, right? And another important benefit that Rescale brings to our users is, when you think about running simulations on the cloud, and if there is an issue, there could be two reasons, right? Either something is wrong with the application or the model, or something is actually wrong with the cloud hardware, right? So Rescale, as a user, we ensure that if someone has a problem, we have the expertise to really dig deep and identify what was the root cause of the problem, and we can fix it. So we have a dedicated support and engineering team who can take care of this. So if I have issues running this job, I can easily submit this job with Rescale support and get immediate attention and help. So that was the important thing that I wanted to cover. A few other things that Rescale brings as value to the platform is, so I told you like there are ways where we can do customization and automation. One of the things that we have actually worked with a particular customer here in San Diego is, so they wanted to run all their batch simulations, the PCB board, which typically took them like 48 hours to run. After the simulation is done, so they wanted the S parameter data to automatically get exported. So what we did here is we wrote a Python script which can actually ensure that once a HFSS simulation is done, it automatically exports the data, right? For this particular case, so this simulation ran. I have all my results here, but the coolest part is now this particular model has 4 excitations, so I can easily export an S4P file once the simulation is done. So this really saves time because the customers now they don't have to go back and spin up another desktop and do the post processing. So we streamline this entire process. Another thing which one of our customers have also asked in the past is, so if we want to run a particular simulation, so is it possible to run the meshing on a single node and run the frequency sweep on a different node? Absolutely, we can do that. And the way is, so we use a two-step workflow, and this is again supported by HFSS. So essentially, what we do is in the command line, first we run the adaptive meshing only on 16 cores, because again this depends on application to application. With HFSS, we've seen that it scales well up to 16 cores, and after that the scaling tapers out. So we are going to run meshing on 16 cores, and once that adaptive meshing is done, we can run the frequency sweep on a number of cores. You can specify the number of cores here. So this again shows that we have the flexibility to submit it as a single job or to break it down into several jobs, right? And the last topic that I want to touch upon is, I ran my simulation, it's all great. Now I want to do a post processing of the data, right? Like, what is my typical approach? So usually once the simulation is done, so I can get an interactive GUI. Let me just zoom out. So this particular simulation, for example, after the simulation is run, so I can go back and look at different metrics, right? I can look at the convergence plot to see if it converges or not. It is as similar to as like, how you would run HFSS on your local machine. You have very similar performance in terms of GUI speed, it's snappy, and essentially even transferring the data in and data out. For example, here I'm looking at the S parameters, the single-ended S parameters, and if I want, I can also create differential pairs and I can look at differential S parameters as well. So from this point, like now, let's say, for example, I can also go back and export the S parameter data here as well. So on the platform, we give the users flexibility to do their work in any different fashion, right? You can run it through a batch job. If you are very comfortable with the GUI, you can run it through the GUI as well. So essentially, we have all the pieces in to make sure that you can do your job with successfully.
All right, Riaz, thank you very much. I think that wraps up the presentation and demo portion of our webinar today. We're going to move on to Q&A, so if you haven't already done so, now's the time to answer or type in your questions into the questions panel, and we will address those one by one. While people are typing in their questions, I want to point out that as a thank you for attending today's webinar, all attendees will receive a $20 Rescale credit that is valid for hardware usage on the Rescale platform. You're going to receive that code in a follow-up email from me within a week. All you need to do is sign up for an account at rescale.com/signup, and then my email will contain further instructions on how to apply the code. Okay, so on to Q&A. We've got a couple questions here coming through. The first one is from Melissa. She asks, when you submit a job, will the user get notified?
Absolutely. Any activity that happens on the platform, so the user will get notified. So for example, if they submit a job, they'll get information that a particular job has started. Once a job is completed, we'll again provide a notification. In this way, we ensure that the users are fully kept up to date.
Great. Next question is from Jamie. Jamie asks, can I do post-processing on HFS simulations in the cloud, or do I have to download the results first? Good question, Jamie.
That's a great question. So as I showed in the webinar today, so once the simulation is done, so you can easily spin up a desktop GUI and do your post-processing on the cloud platform. But if you are interested, you can also download the results as well. So you have a couple of choice, and you can pick any workflow that you want.
Okay, and last question here from Hans. Where is the data stored once the simulation ends? Can I access the results later? I think you also covered that, Riaz.
Yep. So I think that was also covered in this particular webinar. So usually once the simulation is done, so we store all the results in the job folder. For example, let's see. So this particular job was run. And now if I go to my results folder, I have all the information here. This would be stored on the platform. You can specify how long you want to store the information. It's all entirely up to the user's choice, but you can always come back and use it as a reference.
Maybe show how to download these files.
Yeah, absolutely. So usually if you want to download all the files, so what you can do is you can say select all files, and then you can say download selected files, right? So in this way, we'll zip everything into a compressed folder, and then it will be downloaded. And even during the download process, we have a feature called as Rescale Transfer Manager, which will again make sure that we use a multi-threaded approach to download the data faster.
Thanks, Riaz. Sounds like we got some topics for our next installation of our EDA webinar series. We are out of time, folks, so thank you all for attending once again. As a reminder, we're going to send out a promo code and this recording at the end of the week, and this is also going to appear in our newsletter at the end of the month. Thank you so much, and we'll see you next time. Bye-bye.